Hello. Now we are going to look at multiplying expressions where we have to deal with indices more than we have before. So to remind ourselves, an indice is the power on a number. So if I have x squared or x to the power of 2, the 2 is called an indice. It's also called a power. Sometimes it's called an exponent. We have a bunch of different names. For our purposes, they all mean the same thing. They're the little numbers on the top right of our bigger numbers that we would call the base number. So we're talking about where we have to deal with powers of numbers when we're multiplying expressions. So if I have a simpler case here, so I have 6x brackets x to the power of 2 or x squared, I'm going to multiply these things because I have my term sitting next to a bracket. So I have two terms multiplied together. So I'm going to have 6 multiplied by x multiplied by x squared. And x squared means I have x multiplied by x. So in total I have 3 x's multiplied together, and that's all multiplied by 6. So that's going to end up being 6x to the power of 3. I have 6 multiplied by x, multiplied by x, multiplied by x. The x squared means I've multiplied x by itself 2 times, and I've multiplied by another x, so in total I have 3 x's multiplied together. So I have 6 multiplied by x, multiplied by x, multiplied by x. So that's 6x cubed, or to the power of 3, or the indice 3. If I have more complicated stuff, I'm going to multiply my numbers first, and then I'm going to multiply my letters one at a time. So this means I have 3 multiplied by 4, m multiplied by m, k squared multiplied by k. So this is going to be 3 multiplied by 4 is going to give me 12. M multiplied by m means I have 2 m's multiplied together. That's going to be m squared, or m to the power of 2. And I have k to the power of 2 multiplied by k. So this means k multiplied by k, and then I've multiplied by another k, so I have 3 k's multiplied together in total. So that's how that would multiply out. If we have 5 multiplied by our expression, our terms x minus 3, that means I've got 5 of this. So here I had 6x of x squared, here I had 3mk squared of 4mk. This is a little bit more abstract, but here we have it fairly concrete. I have 5 of this bracket. So 5 multiplied by this bracket means I have 5 of the first thing, and I have 5 of the second thing. So I'd have 5 x's and 5 minus 3's because I have 5 groups of this bracket. So I'm going to take that and I'm going to say I have 5 of my first thing and 5 of my second thing. I have 5 of this bracket in total, so I'd have 5 x's in total and 5 minus 3's in total. So I'd have 5 x's plus 5 minus 3's. And that would give me in total 5x, and plus by minus is minus, 5 by 3 is 15. And I can't add or subtract these things because I have 5 of x minus 15 units. I can't add them up here either because I'd have 1 of x minus 3 units. So they're not like terms, I can't add them. But I can say that I have 5 of x and I have 5 of minus 3. And that's reasonably concrete. I can say I've got 5 of that bracket, so I'd have 5 of each of the things in the bracket. The same argument applies when we have something more abstract. So now I have x of this bracket. So just like I had 5 of my simpler bracket here, I have x of this bracket. So I have x is a number. I don't know what that number is, and it can vary, it can change. So x is a variable, it's a number that can change. So I have x of this bracket. Well, that means I'd have x of, I have x of these and x of these. Now this is more abstract, but if we understand the first argument, we can follow the same pattern of thinking for this more complicated idea, that we have an unknown number of the first thing and an unknown number of the second thing. So we'd have x of 2x plus x of minus 12. So we don't know what x is, but it follows the same reasoning as what we've done before. So we'd have, now we just treat this as multiply. We'd have x times 2 times x. Well, that means we have 2, and we have x multiplied by x would be x squared, and we have plus minus multiplied together would be minus. So x multiplied by 12 or minus 12 would give me minus 12 of x. And that's as far as we can go, because I have x squared and x. Those are two different types of things, so I'm not able to add them together. That's as far as I can go. So let's just put this into practice now in a few different examples. So we'd have 9x of this bracket here. So I'd have 9x of 2x minus 1. So following the same reasoning as we did when we just had numbers outside of our bracket, we'd say we'd have 9x of these and 9x of these. So we have 9x of 2x plus 9x of minus 1, and then we just do our multiply out. 9 by 2, we do our numbers first, so 9 by 2 is 18. X by x, I have two x's multiplied together, means I have x with a little 2 up here. That tells me I've multiplied x by itself 2 times. And I have plus 9 by minus 1 by x will give me minus, plus multiplied by minus will give me minus. 9 by 1 is 9 times x. That's as far as I can go. These are not like terms. They both have x in them, but this is x squared. This means x times x, which would be a different thing to just x by itself. And we can continue on. So we have minus 6c of the expression, or the thing in the bracket, 2 minus c squared. So stuff is a bit more muddled looking, but the logic is the same. I'm going to have minus 6c of both of these things. So I have minus 6c of 2 minus 6c of minus c squared. And we have more complicated, we have more letters going on here, but we keep calm and we say we're going to do this a bit at a time. So I have minus 6 times 2. I'm going to do my number part first. So minus 6 times plus 2 will give me minus 12 times c would be minus 12c. And here I have minus 6 times minus, or if we like minus 1, this means minus 1 of c squared. So minus 6 times minus 1 would give me plus 6, and c times c squared would be c times c times c. C squared means c times c. So I have 3 c's multiplied together, and I write that as 6c to the power of 3, or cubed if we prefer. And again, these are not like terms. I have c by itself here. I have minus 12c, and then I have c cubed, or 6c cubed here, which would mean c times c times c. So they're not like terms, even though they both have c in them. Now I have a sum here, and I have 2x minus x times 5x plus 4. And this looks a little bit like I could do some simplification. I have 2x minus x. But I can't do that. These aren't like terms, because this 2x means I just have 2 x's. But this x here is not just an x, it's x of this bracket. So this means I have this many of x. So I can't just directly subtract that from 2. I don't know what that would mean. So I need to take this and do it step by step. I'm going to say I have 2x minus x of this bracket. So I'm going to say I have x of each of these things. I have x of these and x of these. It takes a little while to get used to that idea that we can have an unknown number of something, but that's really all we're doing. We're extending this idea where we'd have 5 of a bracket, and we're saying we have x of a bracket, or here minus x of a bracket. So we're going to have minus x of 5x minus x of 4. So we're going to have 2x, hasn't done anything, it's just come along for the ride so far, and then we're going to have minus 1 effectively. Minus 1 times 5 is going to be minus 5. X times x is going to be x squared. Minus 1 times 4 is going to be minus 4 times x. So now I have all of my terms multiplied out, and now I can compare like with like. I have a 2x and a minus 4x. I can add those things together, so I'm going to group them together. I put my highest power number first, so I have minus 5x squared is my highest powered x, and then I gather my like terms. So I have 2x minus 4x, so I have my like terms gathered together, and now I'm just going to add them up. So I have minus 5x squared. I don't have a like term for that, so it just stays the same, but I have plus 2x minus 4x. So I start at plus 2 of something, I subtract 4 away, and I'd end up at minus 2 of x. And that's as far as I am able to go. Finally, we can have more than 2 terms in our expression. We can have more than 2 terms in our bracket, but that doesn't matter. We're still going to do the same thing. We're going to say I have x squared of each of these things. So I could have, say, 5, just like I did at the beginning here, 5 of this bracket, and then I'd have 5 of each of these things. But now I have something more abstract. I say I have x squared of these things, but the reasoning remains the same. So I have x squared of 7y plus x squared of minus x plus x squared of x squared. It's a little bit messy, but we just keep our heads and we work through. So I have 1 of x squared times 7y. So I'd have 7 x squared times y. We tend to keep our letters in alphabetical order, so I'm going to put my x's first, if we remember to do it. So try to keep your letters in alphabetical order. I think I forgot to there, but try to do that. And then I have 1 of x squared times minus 1x. So I have plus 1 times minus 1. So I have minus 1 of x squared times x would be 3x's multiplied together in total. X times x times x. And then I have 1 of x squared times 1 of x squared is going to be just 1. So you can write in a 1 in front of these if you feel more comfortable, but you don't have to. So I have minus 1 of x cubed, and then I have 1 times 1 is 1, x squared times x squared. So I have x times x times x times x. In total, I would have 4 x's multiplied together, and that's as far as I'm able to go. But I would like to write these in order of the highest power first. So I'd say I had x to the power of 4 minus x to the power of 3. That's the next highest power, and then x squared would be the next power down. So that's plus 7x squared y. So that's how we extend our idea of multiplying our term by our expression, our stuff in our bracket, so that we're able to handle having more indices work to do. And that's what we need for now.